Okay, is my screen visible?
Yes, sir.
Okay, great. So, welcome all to the live session one for this session or the course of this fundamentals of welding science and technology. My name is Devanjan and I am a PMRF over here at IIT Kharagpur. So, I will be taking this live session specially designed for this PMRF scholars, which where we will have some. We will try to interact with all of you guys. Whatever we will be going through the video lectures of that earlier week, we will try to we will try to recap those things once again, and at the same time we will have some questions and answers by which you will be it will be better for you to go through those um, assignments questions, right? Yeah, it's a little bit problematic for me if anyone joins in between. Anyhow, uh, hi Rope, you have any question? Hello. Okay, okay, let me wait for some more time. People are joining. So how we will proceed is like we will so as I was saying, my tab is not working today. Anyhow, I will fix it for next week. uh, so it will be a little bit problematic to do some, what should I say, some pen and paper over here in the presentation mode. Still, I will try to do things in to draw or something like that. I will try to do in paint maybe. So yeah, so how we will proceed is like initially, we will go through those contents of those lecture videos of that earlier week, and then we will try to get those answers for all those questions, whatever will be uh, covered in this live session, right? So, what have been covered in the first week? So it's kind of introductory classes have been done, right? So in your introduction, you have gone through in your introduction you have gone through these classifications of welding process, different kinds of classifications or different kinds of processes of welding in terms of different heat sources, right? Different what should I say, in terms of automation, in terms of, so there will be different mechanisms by which you can classify your welding technique, right? And then you have gone through these parts of weld joint, right? So how your edge should be prepared, those things. So we will try to cover up those things once again uh, in this live session, but of course in brief, which will help you to to solve those answers of those assignment questions. Now, what is a joining process or what is a welding process? Of course, this will come into your mind, right? Uh, Most of you, of course, are familiar with this welding thing. Now, if we are trying to understand what is welding, so unlike the manufacturing processes employed to produce a single component, uh, your joining process will be used to assemble some kind of different members, right? So you want to assemble those different members to yield the desired complex configuration. So if you want to make some complex configuration, you are somehow joining them through some, either you are doing fusion or you are doing some solid state thing. So somehow you are assembling those different uh, complex configuration to make it a single product, right? Now, such a complex geometry is either too difficult or uh, I would say impossible to obtain by using only by those uh, I would say the some conventional manufacturing processes like forming or casting or uh, those machining processes, right? So joining processes are so intimately related to the overall production system that these are also considered to form a class of manufacturing technique. Now, the joining of different elements can be either temporary or permanent in nature, correct? So what will be the mechanism of bonding? Now, if we try to understand in terms of mechanism of bonding, that may be either mechanical or it could be atomic also. So all the joining processes which involves this atomic bonding, those are permanent in nature, right? Now, I should mention over here that the joints which are atomic, permanent in nature, correct? It will be a little bit time consuming. So anyhow, I'm recording the video. You can go through the that video once again. Yeah. So as I was mentioning, if it is involving those atomic bonding, those are will be of permanent in nature. Now we will discuss the basic principles and mechanisms of all such processes. In doing so, we will also consider um different physical, mechanical, or some kind of metallurgical factors also which govern the quality of the joints. So what will happen in mechanical bonding? So in mechanical bonding, the strength of the joint is less than the combined strength of the original members. Is it not? So wherever you are doing the joining, that joint strength will be of course less than the combined strength of the original members. Now in atomic bonding, however, the situation is not necessarily so. Now, there are different criteria, as was mentioning, which is used for classification of the joining process. Now, that is based on the composition of the joint. So, according to this scheme, uh, the joining processes that can be grouped into three different categories. So, there can be autogeneous welding, there can be homogeneous welding, and there can be heterogeneous welding. Correct? Now, in the processes belonging to autogeneous welding, what is autogeneous welding? So in autogeneous welding, no filler material will be added, right, during the joining. And just a minute. So in autogeneous welding, no filler material will be added during the joining, correct? Now, all types of solid phase welding, so wherever melting is not occurring, and somehow to the extent for resistance welding also. So those solid phase welding, resistance spot welding, those are the examples of this category where no filler material is needed. Now, in the homogeneous kind of joining process, what will happen? The filler material used to provide the joint is the same as the parent material. Correct? Uh, Anyone wants to ask anything? I can hear some sound. Yeah, Praveen, you want to ask anything? Okay. So, um, so all types of solid phase welding and resistance welding, those are the examples of this autogeneous welding. Guys, please try to be in time. So it will be very difficult for me to allow in between those presentations. Yeah. Now, in case of homogeneous joining process, the filler material that is used to provide the joint is same as the parent material, right? Now, we have arc welding, you have gas welding, you have thermit welding, which belongs to this category of homogeneous welding. Now, in the process of type 3, which I was saying as heterogeneous welding, a filler material which is different from the parent material which is used, correct? So, guys, can you please mute yourself, everybody? Yeah. Now, in terms of this heterogeneous welding, the filler material that is different from the parent material which is used. So what could be the examples for heterogeneous welding? So we have heard of this soldering, you have heard of this brazing. Those are two such joining process which are heterogeneous in nature, where filler material is not necessarily similar to the parent material, right? Now it may be noted that the two materials which are insoluble in each other, uh, let's take for example iron and silver, which are insoluble in each other, those can be joined by a heterogeneous process, like I was mentioning, these um, soldering and brazing thing, right? Now there are lot of classifications in the joining process. Now I cannot do this pen and paper work as of now. I will fix it as I was mentioning. So you know that this bonding force between two metallic atoms decreases sharply with those interatomic distance, right? So uh, let me spell it. Now if we try to plot a graph, so interatomic force will be decreasing as a function of distance. So if this is r and this is f, interatomic force will decrease like this, right? So there will be a optimum distance where force will be maximum, and then it will starts to decrease. Now, when the distance is, as I have mentioned earlier, when the distance is more than a few atomic spacing, the interacting attractive force reduces to almost zero, but the force increases sharply, and it can attain a very large value when the distance is reduced. So, if it is possible to bring together two metallic surfaces so that uh, nothing but the grain boundaries separate them, those two bodies will adhere with a large force, resulting in what we call welding. So that's the mechanism basically. However, in normal atmosphere, what happens is the metal surfaces which are contaminated with layers of, so of course any kind of metals, whenever they are exposed to environment in air, and if you are allowing them for longer period of time, there will be always oxide formation, right, over the metal surfaces. So whenever they will be contaminated with those layers of oxides and absorbed gases, it will hamper to create those adherence into the surface, right? So these layers are normally a few hundred angstrom thick. So it is not possible to generate a strong attractive force between those two metal surfaces which are brought into contact until and unless those oxide are removed. So that is why the reason before welding you have to always scratch the metal surfaces, or some kind of, you have to use some kind of emery paper to polish the surfaces to remove those oxide formations, right? Now, what are the different kinds of classifications you can think of? So you have those, as I was mentioning, you have those temporary joining, right? We can have temporary joining in nature. Then you have permanent also. Then in permanent, what can be the different uh, bonding, mechanical bonding things you can think of. So you have heard of rivets, right? You can have some kind of stitches, or you can have some shrink fitting. So either you can have riveting, or else you can have shrink fit, or you can have some stitches, as simple as that. In terms of atomic bonding, so these are some kind of permanent or semi-permanent kind of mechanical bonding. So these are mechanical in nature, right? Now, in terms of atomic bonding, you can have solid state welding, right? You can have fusion welding, which is of course liquid state, and also you can have both solid or liquid state. Now, in solid state, what you can think of in solid state welding? Can you tell me what are different examples of solid state welding? Just give me a few examples. Anybody? What are different examples of solid state welding?
Gas welding, arc welding.
Gas welding is not a solid state welding. So solid state welding means you are not going up to melting temperature of the material, right? So if you are doing gas welding, you are generating some oxyacetylene gas flames where you have to have melt the material so that it will fuse together. So in solid state welding, you have examples of cold
Friction
welding,
welding.
uh
Friction welding.
friction welding, yes. So friction welding is an example of solid state welding. So in friction welding, again, there are different kinds of friction welding. So depending on your, I would say, some mechanism, or yeah, there are different kinds of friction welding. You can have ultrasonic welding, you can have friction stir welding. In friction stir welding, there are linear friction welding, you have rotary friction welding, then you have diffusion welding. Have you heard of this diffusion welding term? It's just pure solid state diffusion, which takes a long time to diffuse metals into one another. So if the metals are in solid state, diffusion will take time, right? Now, if the metals are in liquid state, it's very rapid in nature. So because in liquid state, the metal atoms are kind of haphazard in manner, and they create spaces in between. So it's very easy to diffuse if you are joining similar metal, or else if you are joining different metals, if it's very easy to diffuse one into another in liquid state. That is why the diffusion is very rapid in liquid state welding or fusion welding, right? Now, I was mentioning in cold welding, there you can have pressure welding, ultrasonic welding, um, explosive welding is another example of this solid state welding. Now, what are there in liquid state welding? One of you was talking about this gas welding. So gas welding is an example of liquid state welding. Then you have, of course, shielded metal arc welding, SMAW. Then you can have a resistant welding also. Actually, if you are thinking of in terms of a source of heating, gas welding comes under a chemical heat source because you are generating a oxyacetylene flame through mixture of oxygen and acetylene. It comes under a chemical heat source, right? Uh, Same is true for something called thermite welding. So thermite welding, gas welding, they comes under chemical heat source, right? Sorry. Yeah. Now, what is there for solid liquid state welding? I talked about brazing or soldering, right? In brazing and soldering, they are solid liquid state welding. Now, what do I mean for this solid liquid state welding? What is happening during brazing or soldering? Can anyone respond? So basically in soldering and brazing, what is happening? Those are carried out by, uh, as I was mentioning, for heterogeneous weld, you're allowing a molten filler material to flow in the gap between those parent bodies. So you're creating, so you are creating, let's say, this is one of my metal. So basically, you are creating one gap where you want to deposit those filler material. It could be layer by layer, it could be in bulk volume, whatever. But you are basically filling up that gap by allowing that molten filler material to flow into that gap. You know? Now, yeah. So obviously, this filler material has to have some melting point, which is much lower than that parent body. So if this is my P melting of filler material, and if this is my P melting of parent material, so this should be, sorry,